Ph261, Chapter 8, homework problem. I believe this one is number 8. So it says, a 3.7 kilogram bundle starts up at 30 degrees incline with 123 joules of kinetic energy. How far will it slide up the plane with the coefficient of friction being 0.3? So, well, we can list our givens. We have a mass of 3.7 kilograms. We have a theta of 30 degrees. We have a force of 123 joules. And how far up will it slide if we know that the friction coefficient, whatever, is 0.30. Okay, so it's going to look a little bit like this. You've got this block, theta, and of course you're going to have mg cosine mg sine. You're going to have fn. You're going to have fa, and of course you're also going to have fk in the opposite direction. Now, from here, we can say that the kinetic energy is equal to the force here. So that's kinetic energy. And potential energy, or the change in the potential energy at least, is going to be mgh. And, well, this is going to be m mass gravity change in x, sine theta. Okay, and we know that the work is going to be force times displacement. Or we could say that it's the change in potential energy, or change in energy plus change in energy loss due to friction. And that is going to be, energy loss due to friction is just going to be Fk times delta x. Change in Fk is going to be friction coefficient mg cosine theta change in x direction. Okay, knowing all of this, what we can say is that work is also equal to the change in kinetic energy. And work equals the change in U plus the, of course, change in the friction here. Or, yeah. And that's the law right here. This is the law of conservation of energy. Knowing this, we can actually rewrite this to say that, because we have delta x in both, delta x is equal to the kinetic energy divided by mg sine theta plus the friction coefficient mg cosine theta. Or we can say, plugging the numbers in, changing x, equals 123 joules divided by 3.7 times 9.8 sine of 30 sine 30, and we're going to have the friction coefficient. That's going to be, let's see, 1/2 times, or 1/2 plus 0.3 cosine theta, and then changing x, equals 4.46 meters. That is how you do question number 8.